hi there, ho there, everybody. We've got What's Up with Giancarlo back again. Let's go. So we've got topic 6, lesson 5 today. This is we have this same video, same lesson, but these are some different notes that we're going over this time, okay? So we skipped topic 6, lesson 4 because we went over a lot of it in topic 6, lesson 3. So now we just took one little piece of 6.4 and just added it to topic 6, lesson 5. So that's what we're rocking with today. So we got draw conclusions from data. I can use statistical measures and data distributions to compare and draw conclusions from data. All right, let's get moving. So this is what I'm talking about that we took from 6.4. This making a stem and leaf plot with numbers. So this stem and leaf plot is in topic 6, lesson 4, but I just added it to the topic 6, lesson 5 notes. Okay? So this is really not example 1 for topic 6, lesson 5, but whatever. Make a stem and leaf plot with the following numbers. So the numbers we have are 12, 13, 23, 27, 30, 34, 38, 41, and 46. Okay? So what little Einstein's telling you to do, we place all the 10 values on the left side of the table. That will be our stems. Then the 1 values on the right side of the table. That will be our leaves, okay? So even in different colors. So we've got the 10s, which is 12 and 13 has a 1 for the 10 spot. That's where the 1 comes in. 23, 27 has a 2. That's the 20s. That's the 2 in the 10 spot, in the 10s value. 30, 34, 38 all have a 3 in the 10s value, and then 41 and 46 have a 4. So now we take the 1's values and put them in 2, and then we separate them by a comma, 3. So this 1 is 10 plus 2 is 12. 1 plus 10 plus 3 is 13. So on and so forth. 2 is 20, 23, 27, 30, 34, 38. 41, 46. That is how you work out a stem and leaf plot. Okay? That is how you write it out. That is how you read it. Please pause the video and take your notes. Okay? You can go at your own pace. So let's move on. I've got the real example 1 for topic 6, lesson 5. Use statistical measures to compare 2 populations. Okay. So we've got 2 populations, one in 2023, one in 2024. These 2 populations are burpees completed by 20 students. I mean, they could be the same 20 students, they could be 20 different students we'll just call them the same 20 students. In 2023, they were in 6th grade. Now 2024, then in 2024, they were in 7th grade, okay? So we look at this is a line plot, and we say 1 kid did 20 burpees in 2023. 2 kids did 21. 2 kids did 22. 4 kids did 23. 5 kids did 24. 3 kids did 25. 2 kids did 26. And 1 kid did 27. That was all 20 kids in 2023. Let's look at 2024. 1 kid did 21. 1 kid did 22. 1 kid did 23. 1 kid did 24. 2 kids did 25. 2 kids did 26. 3 kids did 27. 4 kids did 28. 3 kids did 29. And 2 kids did 30. Okay? So that is the line plots. Now we know everything about that. So let's look at the peak. You can use the peak, the number with the most dots of data points on a line plot to compare 2 data sets. So I'm looking, the peak in 2023 was 24 burpees, where the peak in 2024 was 28 burpees. Okay? So it looks like they did more in 2024 because they had a higher peak. Okay? That is just what you can visualize, what you can see from the line plots. Okay? Please pause and write all of this down. That is what peak is, the number with the most dots. So we see 5 dots over 24, that's why the peak is 24. We see 4 dots, that's the most dots on 28, that's why that's the peak. Okay? Let's move on. You do not have to rewrite the line plots. You already wrote that down once. Alright? I just put it down if I was going over it in class, but you do not need to do that. So, they're asking about the means. So you add them all up. 20 plus 21 plus 21 plus 22 plus 22. And then you divide your answer by 20. Same thing for this one. So they just straight up give you the mean. They're saying the mean for 2023 is 23.6, whereas the mean in 2024 is 26.6. Okay? So you can compare them by taking the difference. So the difference of the means, I get 26.6 minus 23.6 is 3. That is the difference. So that shows the difference of the means show that the number of burpees done in 2024 is about 3 more than in 2023. So on average, kids did 3 more burpees than the kids did in 2023. That is what we all know, that mean is the average, because we take all the numbers, add them all up, and then divide by the amount of numbers. That is the average and the mean. Okay? Please pause the video, write it down. Alright. And the last, and just going back to this, the mean is the measure of center. Okay? Mean is measure of center. And mean goes hand to hand with range. There's no outlier. It's not really skewed at all. So it's mean and range. Those are the measure of center and measure of variability. Okay? So once again, you do not need to write this down. So we're looking at the range. The range is the greatest number subtracted by the lowest number. So in 2023, the greatest number is 27. The smallest number is, the least number is 20. So 27 minus 20 equals 7. Okay? For 2024, 30 is the greatest number. 21 is the smallest number. So 30 minus 21 is 9. Okay? The range for 2024 is greater than 2023, 7. Therefore, there was more variability in 2024. It was more spread out. This is more together, okay? That means there was more variability in 2024. Some kids scored low, some kids scored higher, okay, than they did in 2023. Pause the video, write this down. No outlier, no skewed data. It's mean and range. Now let's look at this. Example 2. So, interpret statistical measures comparing two data sets. Number of butterflies seen each day. So we have a double box plot. We've got 8th graders right here, this box plot, and then we've got 7th graders for this box plot. Okay? We've got our least value, our greatest value. We've got our lower quartile, that's what LQ stands for, and our upper quartile, which is what UQ stands for. Then we've got the median, which is the M, and then we've got the same things for the 7th graders. Okay? Go ahead, write all of this down. Pause it. Okay? Let's move on to the questions, or the measure of center and the measure of variability. So we're looking at the medians. We're comparing the medians. Okay? So 7th grade had a higher median, so they had a higher measure of center. Okay? So they had 24 compared to 22 in the 8th grade. Okay? Comparing the IQRs, we should all know what IQR means, interquartile range, and how to find it. If you do not, IQR equals the upper quartile subtracted by the lower quartile. Okay? When we do this, the upper quartile for 7th grade was 28 subtracted by 18, the lower quartile. That is 10. The 8th grade upper quartile was 24 subtracted by the lower quartile, 14, is also 10. So 10 equals 10. That means they have the same measure of variability. Okay? They will have the same measure of variability. So nothing really changes between them except for the fact that the measure of center was higher for 7th grade. Okay? Go ahead, pause the video, write all of this information down. Go ahead. Moving on now. Example 3. Draw conclusions from summary statistics. So we've got data of test scores in the histograms. Okay? These are called histograms because they're all the bars are touching. Okay? If the bars were not touching, if they had space in between them, they would be called bar graphs. But these are touching, therefore, histograms. Okay? So these are the number of students. Okay? Test number 1 scores, test number 2 scores. Number of students ranges up to 6, and then these are the test scores. Sorry about the poor handwriting, but I'm trying my best. Alright, test scores. So, hurry up, pause, copy down all of this information, okay? There will be questions on the next slide about this information. So you look at these histograms, and then you're able to answer the problems that they're showing from the information that they're showing. Okay. Let's move on. So they're asking you questions about the histograms, about test. These are all A, B, and C are 3 questions about test number 1. Test number 1, where A, B, and C in green are test number 2. So what was the lowest scores? What was the lowest that somebody scored on the first test? Well, if you look back at the histogram in your notes, you should see that one person scored between 50 and 59. Therefore, the lowest score possible was 50 through 59. Okay? Question B about test number 1 scores. What was the highest scores? Well, you go back to the histogram. Let's just go back. We see 2 kids scored between 90 and 100. So therefore, the highest scores were between 90 and 100. Question C. How many students scored between 70 and 79? 70, 79. We look at that category. 1, 2, 3, 4, 5, 6. So 6 students scored between that. Okay? Now, the lowest scores for test number B, test number 2. Well, nobody scored in 50 through 59, so one person scored 60 through 69. Therefore, that is our answer. Okay? Letter B, highest scores. We look, the highest score possible is 90 through 100, and people scored in it. So the highest scores for test number 2 would be 90 through 100. Okay? Now, C, question C. How many students scored 50 through 59? None. Nobody scored 50 through 59 on test number 2. The grades got better. Yippee! Yeah, woo! Okay? So that is how we read a histogram. And this is, you can use statistical measures and data distributions to compare and draw conclusions about 2 sets of data. These are key concepts, and you can go over this if you'd like. Okay? But the lesson is over, and we're done for today. We're done with this lesson, okay? So get on with the homework. And remember, if you're watching this video, you're part of the class. I'll see you next time, everybody.